Okay, so I'm going to create a, so what can we do on GitHub? And I told you that you can find code, you can find algorithms that others have built. So if you are in the GitHub website, there is a search box there. Okay, so give me a topic you are interested in. Any topic. Evapotranspiration. You type that, you hit all GitHub, and that is a search box, and it's telling me that there are 277 pieces of code that deals with evapotranspiration. Now, here comes our work combing through this data and assessing if any piece of code is useful for us. So, for example, these three letters, GEE, is Google Earth Engine. So if I'm learning how to do things in Google Earth Engine, this repository will be interesting. They are using estimation for evapotranspiration using the Pegman-Monti approach. Or here is a Python package to calculate reference potential evapotranspiration. NASA has published a piece of code that allows you to estimate daily evapotranspiration from Landsat data. So here is where we're going to start choosing what we want. We can choose by language, Python, R, Jupyter Notebook, JavaScript, MATLAB. Which language are we familiar on? Nowadays, everybody's moving into Python. Who knows Python here? Who is at least a tiny bit familiar? I'm not saying a pro. Okay, tiny bit. Have you used Python? Okay. What have you used? Okay, good. Just use MATLAB. Okay, I love MATLAB. I used to love MATLAB. I was really good at MATLAB. I could code in my mind in MATLAB. Okay, I was that good. But now the world has moved into Python, so I had to learn from scratch Python. But the good thing is, if you know coding, moving into another language is not that hard, like starting from absolute zero. So we're going to use Python, and but Python in Jupyter Notebooks. Why? Because Jupyter Notebooks makes Python easier. So let's say we're looking into evapotranspiration models or algorithms that have been written in Jupyter Notebook. So I can click in that, and now I only have 41 repositories that I have to come through. So I can, let's say, look, it says the first one is very interesting. It says predict evapotranspiration using long short-term memory networks, which is machine learning in TensorFlow. So if you understood this last part, this is an AI model. This is or this other algorithm. If you're working with, remember Larry Hibbs, who was here yesterday? He worked with eddy covariance instrumentation. Here is a piece of code that takes that raw data that come from those sensors and estimate evapotranspiration from those sensors. So there are people like that who have put that code accessible to anybody. So let's see. Let's look, and this is the one that you need to use. Remember in the first lecture I gave you links to GitHub. So let's look for one. Let's look for, what's the name? GEE map. And I put it on the search box. Okay. Now, the one that I'm looking for is this first one, a Python package for interactive mapping with Google Earth Engine, IP left, and widget. If I click on that one, let's say that's the one I want. Okay. There's going to be a folder view, but at the bottom, there is a README. And this is a good practice. When you publish code or you build what we call it a GitHub repository, it's important to create this README. The README, his README is way advanced because he has icons in it, but ignoring that, all of this is text and hyperlinks, and that's easy to do. So he's explaining that this is my repository, where is the documentation, where is my Python libraries, the PyP, the CondaForge package repository, the examples, tutorials in YouTube, and what's the license. The license is going to be something that, I mean, have anybody explain to you how licensing works a bit? If I have an MIT license, what does it mean?
That allow you to use some software or something, so something can be public, so everybody can use it. But
Yeah.
something is like private, and for you think you need some license.
Yeah. The license in this sense is telling you how can you use the code. If the code is accessible, like this one, I can see all the folders and all the data there, means it's free. But if he says here is an MIT license, and there are variations of this, there is the MIT, there is the open access license, the GNU license. That means that in MIT, I think you can use the code, but when you publish or you produce a work, you have to provide credit. Like this code was possible with the algorithms provided by the author of this code in this repository in GitHub. So you have to give him full credit. So and it's important to do that. It's important to give credit to software that has been provided. Okay, now let's say I'm interested on this. I want this code. I want to use it for my learning. Okay, so what we need is to create an account on GitHub. Okay, who has an account on GitHub? 1, 2, 3. Okay, if you don't have, go to the top right, click sign up, and create a free account. So I'm going to sign to my account. Change it. Let me know when you're done creating that account. You should be able to access a page like mine. It won't look the same, but it has the 3 sections. Your username. You won't have libraries here. I do. Here might be empty. And here you might have something or not. Okay, have you completed? I need feedback. I don't know where you are. Okay.
Yeah.
Yes. Okay. Do you see a page similar like mine? Yes. Okay. Let's look again to here. In now the box, the search box has changed positions. It's next to the cat icon. So you can put GMap there. Okay. Okay. It's the same search, but now the search box is in a different location. So we click on GMap. Okay. So in GitHub, there are ways to follow up code. So this author is always updating his code. I want to keep track of, it's like getting notifications about it. So you can, here where it says start, you can click on start. And if it's yellow, you are now following updates from this guy, from this repository, from this algorithm folder. Okay. Now, start means now that you go back to your account. How do you go back to your account? You click on the cat here on the upper left. So you should have, let me see, where are they? Here in your icon, where you're on the upper right, if you click there, you can go to your stars. And here is GMap. So one day I cannot sleep. I'm bored. I saw everything Netflix. So you want to look, okay, I wonder what's something of interest in GitHub. You just start putting keywords like soil moisture water balance or eddy covariance or runoff estimation or image classification, and you start perusing through those repositories. You say, yeah, I like the ones on MATLAB. So you sort it out by the language, and you start looking at the code, and you put the stars, and automatically this list will be filled up. So now you have like your favorite folder in GitHub there. That's one way to use it. Okay, that's the most basic way. Okay. Second, okay, those who are GitHub experts, have you ever cloned a repository? No? Okay. Next step. Okay. Let's click on the cat for now. Okay. Let's say I want a piece of code that deals with runoff. Let's click there. Let's type runoff. Okay. I have this list. I check on the code, on the language, I say Jupyter Notebook. Yes, Jupyter Notebook, that's what I want. Okay. Let's say, so you should be getting a similar 59 repositories, right? We're not going to use any of that. This is not part of the, we're not going to use run of code in our class, but I'm showing you an example of any topic. But now I can start any of this, and I can click on the star here to do the same starring. Say, I want this one, I want this one, I want this one. But now starring doesn't mean you have access to the code. You just put a marker, a favorite marker to that folder. I want the code. I want it to be on my archive. Okay. How do I do that? Okay. Let's start with the first one. Pangeo long short-term memory example. This is machine learning for Bruno. Okay, let's see. It says launch binder, blah, blah, blah. Okay, I don't like this example. I want something that has code. Let me see. Let me see this one. Yeah, I like this one. Okay, the code that we're going to use in your 59 repositories, go to the very end. And there is this one, Royalosgene, a beginner guide to carry out extreme value analysis with codes in Python. Do you see it? Okay, click on that. As I say, I can put a star on it and it will be on my favorite list. But what I want is that code being on my archives. Let's say the developer will die soon or will stop working on coding. He might delete all his repositories. Despite they have a star, if the author deletes their repositories, it's gone. The star sent me to a not a 404 page, no data or no access. So to ensure that I have a copy of that code, what we can do is call it fork. This icon, fork, will create in my GitHub Cloud account a copy of that code. So if I click fork, okay, will send me to this page. Create a new fork. Owner is going to be your GitHub account, the name of the repository. You can keep the same name, you can change it. Okay, so in this case, we're not going much to complicate about branches, but we're going to copy. In this case, there is only one branch, the master, or there is only one person working in this code, so there is just one branch. So let's leave everything as it is, and let's click create fork. Now you see that I got an error. Did you get an error? Okay, so it didn't do the job. Okay, let's click again fork. Let's change the name. Shorten it out, and then create fork again. Oh, still. Oh, description. Let me see. Fork. Oh, description. Sorry. Here. Wow. Okay. Okay. The description is too long, not the repository name. So create fork. Done. Okay. Were you forking success? Okay. Now, if you click, now you see that my username in GitHub is followed by this long name. So now if I go to my icon on the upper left and I go to your repositories, In my case, I have too many, but in your case, does it show the one that we just cloned? Yes, everybody was successful on that. So those are the two most basic steps on GitHub. I mean, that's let's say that's computer science 101. Okay, so, make a list of favorite repositories, and second, getting a copy of that code to use it on your personal work. Okay, so we're good there. All right, now I need to work on that data. Okay, I need to work. So to work on that data, now that I have a GitHub account, and this is the part now that we go to the computer. Okay, so if I want to work on my computer, how many of you use Windows? All of you? Yes? Okay. Then it's simple, because I don't know much about Mac or Linux. I used to be a Linux geek. I used to format my laptop when I was a student, and every year to see if Linux has reached the equivalent or being similar to Windows to work, and I was always disappointed. So, okay, so now to work, the easiest way to work with code in GitHub in Windows, the easiest way is to download the GitHub desktop software. So I will open a new tab. I will type GitHub desktop. Okay, everybody there? Go to GitHub desktop. Okay, if you're working on your laptop, you can download it. If you are on these computers, just watch how the sequence goes. And that's the reason I'm recording, so you can access this later. So download it for Windows. I don't have it on this laptop, so that's good for me. Okay, open. Okay, it's open. I don't recommend installing GitHub desktop on a shared computer, like a laboratory one. But because GitHub requires a username and a login, but your files stay on the computer. So if somebody, let's say, mess up with your folder, that software will try to synchronize it to the cloud. If it's deleted somewhere, it will delete on the other computer or on the cloud your files. So only on your personal devices. So welcome to GitHub. Create your signing into GitHub. Open. Okay, that's my name. Finish. Correct. This is, now I have the GitHub software in my laptop. And you can see that I have a lot of repositories, but here is the one that we just cloned, right? Or we fork. So we can now, what is showing this list is what you have on the cloud. To work on it on your computer, you have to clone it. Clone it means clone it from the cloud to your computer. So here there is a button on there. If you click on your repository and then click clone, at the bottom there is clone dividing water, and it will show something like this. Do you get this window? Yes? Okay. Now it's telling you the address from which the code is going to be brought to your computer and where it's going to store it. You can change where. I can put it on the desktop. I can put it on a specific folder. In this case, it's going to put it in Documents, GitHub, Beginner Code. You can change that with the choose, but I'm okay with that location. I will say clone. Okay. Now it's asking you GitHub is realizing you fork this repository. It's asking you, are you planning to use this code to help the original developer, which is the first option, or for your own work, separated from that guy? I don't know that guy, I just wanted his code. So in this case, I just want it for myself. I'm going to say for my own purposes and continue. I mean, you can collaborate with him. It's just that in this example, whatever mess we do today here, we don't want to send that to the guy. We were just doing an example for ourselves. Okay, so where is the data? Where are the files? Well, the files are where you decided they can be stored. So you go to Windows Explorer. Mine was in Documents, GitHub. All the code is there. Okay. So now if I have MATLAB, I can open the files in MATLAB, run Python, Jupyter. I can do all the operations I want on this code. Okay, right now it's exactly as we fork it, and now we clone it locally to our computer. So now let's open one file. Let's see. Let's open the DDF data os.txt. Okay, it's a text file. This is the data to run his code. Let's say we say, okay, the title doesn't make sense. Let's change duration or period. Okay, I modify the code. And I save, and I say, save. That's it, minor modification. Okay, now, let's say I'm done for the day. I complete my 20 hours of work for the week. I'm going home. All right. So now, before you leave, it's important that your local changes are synchronized to the cloud. How do I do that? I go back to GitHub. I open GitHub, and it's telling me that in the past, it said duration. But now there was a change that says period. So GitHub is smart in that way that once you clone it, it's keeping track of the files. And when you change something, it will tell you, hey, here is a change. Okay. So now, okay. So I'm tired, it's 5 p.m., it's Friday. Let's say, does any of you drink alcohol, soda, water? Okay, so let's say it's 5 p.m. I want to go to drink water with my friends. So maybe, okay. So, but I need to do this step because my professor told me I need to do it. Okay, so I need to my local changes are not synchronized to the cloud. I have to tell GitHub to do that synchronization. So I'm going to tell here, here at the bottom, here, we need to tell them what we change and why. So change her, what did I say? I can say period is a better term to describe this column. Okay, simple, yes. Now I say commit. Okay, now I told GitHub the reason why I did that change in the code. So now GitHub in his metadata or on his tracking software has that information. Now the last step is now push it to the cloud. And that is this one, this button, push origin. Done. So now if I go back to GitHub on the cloud, and I look for what was called our repository. In your case, should be here. If you click on that, it's going to say the other files were changed or modified 5 years ago, but the one that I work at just right now was modified a minute ago. If I click on the file, it doesn't, now it's a spirit. So next time you come, or let's say you lost your computer, you are working on the desktop computer in your office. Now the code is up to date, and you can work on this version of the code. So that's how GitHub works. Like you have code there, you clone it locally, you work on it, you open that file, Word, Excel, in any language, you modify it, the software keeps track, you open the GitHub software, you tell them why you did the change, and then you store that data and then push it to the cloud, push to origin. Okay, is that clear? Because that's the homework. It has to be clear because you're going to do a homework on this. Okay, what is not clear? Huh?
Homework.
The homework is not clear? No, the homework is that you will create a tutorial.
Oh.
Okay, you will create a tutorial on a repository that you find interesting. That's the homework. So if you are missing a step, I will know. Okay, so what is not clear so far? Because we're going to close with the easy part. Now we're going to move to the hacker version of it. No? Okay, good. All right, we're happy. Okay, now we know, hey, I'm a hacker. No, you're not yet a hacker. Okay, now you will become a hacker. Okay, how many of you have a HydroShare account? Okay, let's go to HydroShare. Why HydroShare? One reason. It's a standard environment for all of you. Every computer is different. So if we try to run Python on your computer, my computer, and your computer, there will be library conflicts. Your computer might be in 32 bits, mine 64, or your Python version is 3.1 and I'm in 3.6. So everybody might have a different configuration, but in on the cloud, everybody's working on the same. So if I have issues, you also have issues. So if I solve mine, I solve for all of you. Okay, so sign in. Okay. And now, minimize this one. Okay. HydroShare. HydroShare is useful for who can explain what is HydroShare?
I'm sure, but I think it provides the hydro information, and somebody can also share their stuff that we, for some cases that we work on watershed.
Yes, but it's not limited to watershed. Yeah, go.
So GitHub to example, GitHub to code in it, create it with everything, files, images,
Mhm.
like online repositories, all
Yeah.
things that cannot be.
Yeah, and this is GitHub is for any project. I can have high school students working on a programming code, and they can publish in GitHub. HydroShare aims to be more scientific, aims to receive code as in GitHub, but also data, text files. Indeed, GitHub, we don't run into the issue of the file size. Remember, we said if you're processing a satellite image in GitHub, just cut it a little piece so you don't have a bottleneck of data synchronization. Now, in HydroShare, you don't have that. You can put massive amount of data in there along with your code. So, but GitHub is more designed to be used at the end, late stage of your project. What does it mean? In the late stage means that you are already finishing your work. You are finishing your paper, your scientific paper. So you have your final version of your code or final version of your data, and you put it in HydroShare. HydroShare will generate what is called a DOI, a digital object identification, that you can cite in papers. So it's a standard, but once you publish, you cannot change anything. The code stays static, the data stays static, everything is static. So it's how I see it now, and I haven't heard much about latest updating HydroShare, but that's how you use it. Is you're publishing your paper, you also upload your data to HydroShare to have a unique and changeable DOI, or that you can cite in your paper. The code and the data of this article has been published in this link. So anybody who wants to is looking at your paper and then, oh, he published his code and data here, they can just go to HydroShare, download it, run it, and get the same results as your paper. What is called replicability. So it's a practice that we are pushing forward in science. A lot of papers don't have that capability, or don't provide that access, that they publish results, but nobody, only the author has the data, the code, and the results. So with HydroShare, the idea is that you have the paper, but also you can also access the data and the results and the code. So
the UI is provided by HydroShare.
by HydroShare.
So is it mandatory that we have also paper regarding this data? Or
No. You can publish data without a paper, but if you're publishing paper, it's good that your data has already a DOI. Okay. All right. HydroShare. What I like about HydroShare is that they have been building apps. So putting aside the publication of data and code, they have computational resources. If you click on apps, there are several in there. There is data series, which I haven't played much with it, but what I like is this one, Jupyter. So if you click on Jupyter, And it's saying, yeah, if you lose your data, we're not responsible. Don't use it in dangerous ways, and don't blame us for anything. Okay. You click agree, sign in with HydroShare. You will get a screen like this. Authorize. You should get a view like this. Do you?
No, I
Yeah.
didn't.
Okay. What does it say?
Go to the cloud comp.
Yes.
Let me see. Okay. Ask to join. If you get that link, there is a blue button that says ask to join.
You have to explain something.
Yeah, say that is for this class, and they already knows me that I pester them about giving access to more people. No, it's a excellent resource what HydroShare has built. So they will respond that in a day. So if you got that message, follow the screen. You might not get access at least for a day. Okay. So once you click into that option, you will be listed with these options of servers. So HydroShare basically is environment.
I joined, still I'm same page. I didn't.
No, this is going to take a day,
Oh.
1 day. It has happened in the past. So from now on, follow the screen, please. Okay, so who got this page? Okay, one, only one? Okay, follow the screen. Okay, tomorrow when you are doing your homework or Monday. Okay, so you will get the server options list. There are from Python to R, RStudio. Summa modeling is for, if I remember well, is for groundwater. Warp Hydro, this is for running land surface models. This is for training that they did a while ago. So which one are we going to use? We're going to use the first one, the Python. We click there and we click start. Sometimes this happens that they take a bit of time.
So this recording is gonna be on campus, right?
Yes. Yep. That's the idea. I know that sometimes the lab especially requires a second look. So to not to miss what I did. So far, GitHub has been fun, right? It's just a step, a step, a step. Before you go drink water with your buddies, synchronize your code with the cloud, and off you go. No worries. Okay. All right. Once you go there, how many of you have used Jupyter notebooks? Okay, 4. Okay. Jupyter notebooks, it's let's say a more elegant way to interact with Python. A notebook is just basically let me see. I can open a Python notebook. A Python notebook is basically a sort of cells where you can pass commands. I can say 2 plus 2 run 4. I can pass earth equal divide by 23. Earth. So it's programming. MATLAB has this option too. It has the MATLAB notebooks. So it's the same. So in every cell is independent. I can rerun the first one. I can rerun any cell. And that's the danger of this, because it doesn't follow a sequence. If you change something, for example, I say 21, but I don't run it. If I run this one again, it's giving me the same number. It never check back if I change the number. So that's the danger of when using Jupyter Notebook, that we have to make sure we run everything up before that cell to have the most or the updated results. So I can say there is an option, run all cells. And now it runs the first, the second, the third, until the last one. So we're going to use this to deal with remote sensing data, this environment. Okay, so now that our Jupyter hubs is there, what we're going to do, what we need to do is we're going to organize. Let's say you have 10 cloned repositories in GitHub, 10. Okay, like we did for the last one, but 10 of them. And you want to have them organized here in this environment. So the first thing I would recommend is to create a folder. Let me see if that allows me to create a folder. Oh, here, new folder. And I'm going to say git _ clones. Okay. I am in git clones. If I double click on that, there is nothing. Okay. Now it comes the hacking way of GitHub. In Windows, I can use the software to do the synchronization. This is Linux. This Jupyter Notebook is running in a supercomputer in Linux. There is no Windows there. So everything has to be done by commands. Okay. So so I have my folder. It's called git clones. Okay. Now, how I bring that repository that we just make the change to Linux? Well, to that, we have to work on a terminal, on this icon, terminal. So I'm going to click on terminal, and I will get a screenshot like this. Okay, so this is the integration of HydroShare at GitHub. Okay, so what it says is saying base. Base is the Python environment. It's the basic Python where I am. It's saying Jovian. Jovian is, I don't know what it means, but it's like, this is the default environment, and then my username on GitHub, which is my last two names. So here we need to apply a little bit of coding. I need to know where I am in the file structure. Okay, have you ever used command terminals? Yes, okay. Okay, if I need to know where I am, where I am, the command is LSL, no I. Okay, so I need to know where I am. I'm in where I am. I type ls, is telling me, it give me the list of the folder that I'm seeing. So I'm going to compare what I'm seeing here with what I'm seeing here. So if this list is showing me what I have here, I am in the root folder. The root folder is marked by this slash. And if I have text next to that slash, I'm inside that folder. So if I open git clones, you see how this changed it? Now I have a slash git clone. That's where I want to be. And I need that when I enter the ls command, shows me what is inside the git clone, which is nothing. So how do I do that? How do I now navigate from the root folder to the git clones folder? How? CD. Okay, I need to click on my terminal. CD space what? The folder name. You start typing git, and then you can use the tab command, and it will fill up the rest of the name. Okay. Now, if I do cd change directory, now you see that my name now has a slash git clones. This part. Okay. Now I'm going to verify. Am I really there? ls. Showed me nothing. That means I'm in the right directory. So change directory cd name of folder. Enter. Okay. Yeah, that arrow down and left is enter. Okay, so now I'm here. So in the terminal, I'm in that folder. Now, why I need to do this step? Because I want that Git repository to be in this specific folder. I'm going to import 10 of them. Okay, so what I'm going to do now is I'm going to go to GitHub. I'm going to go to the folder that I am interested in. So you go to your repositories. Okay, click it. Okay, this is my folder. Oh, this is my repository. I want to bring it to HydroShare. Okay, so here is the explanation. Here is the file that we changed 22 minutes ago. You know, time goes fast. Okay, so I need now to bring that code into that environment. So what I'm going to do is I'm going to click in the green button, code, and I'm going to click on the copy of this address. Okay, copy it. Now I go back to HydroShare, and I'm going to say git plot Control B. Let's see what happened. Done. I have now the code of the repository in HydroShare. So how do I bring from GitHub to HydroShare git from address. Git address. Easy peasy? Easy peasy. Okay. Okay. How do I know that the code is there? So now I can go to that folder. There is the code. Because we select the repository that has Jupyter notebooks, I can open any of those. And I have the code. I can now modify it and do the same. Now, what I'm doing this, I want, so, okay, are you following me till here? Is everything clear with these 3 steps? Yes? Okay, very good. Very, very good. Okay, so this says this is number 5. Let's see, where is, okay, this is number 1. Okay, it says import. Okay, today I'm not going to deal with Python. We will leave that for the next session. Today is you being able to synchronize folders and data from Jupyter, from GitHub to HydroShare. Okay, so, okay. Look, you can do plots and see the data files. That's awesome. Okay. Now, let's say to this one, we're going to add, say, this is an example of using GitHub and HydroShare. I'm modifying the file. So this is not code, this is text. So I need to put it on Markdown and I can run it. So, okay, but I have modified the file. So I'm done with this. Save it. And here, where my mouse is saying this file was modified seconds ago. Okay, I modify my file. Remember on Windows, when I modify a file, the GitHub software detected I have to put a command, no, I have to put the explanation why I was changing the file and then push it to the cloud. We will do the same now here. Okay, now to do that, I need to bring back my notebooks because I don't remember all the steps at this point. Let me check. Where is that? Projects. And I'll give you this document. These are my projects now. Download. Yeah, here. Okay. I have this PDF that helps me remember commands. So you will have a copy of this document. So what I want to do, what I have done to this file, not this one. What I've done to this file, I introduced text on this file. So right now it's different than the one in the cloud, right? So I need to synchronize my changes on HydroShare to GitHub. Okay. So to do that, in this document that I created a while ago, we're going to check the option. Okay. There are plenty of, let me see. Yes. Is the step 2.8, committing and pushing files to Cloud Git repository. So now what I need to do is I need to make sure that I'm in the folder where my Git files are. Let's say I am in CD. Okay, I need to check that I exactly in the same folder where I changed the document in the terminal. Here, it doesn't matter. If I change here or to any other folder, it doesn't matter for the Hackaway. Here in the terminal, I have to be in the folder. So where I am, ls. Oh, no, I need to be in the git clones folder. cd, git, press tab. I'm in the folder. Can I verify? ls, a beginner guide. Let's double check. A beginner's guide. I'm in the folder. In the terminal, I'm inside the folder. Okay, now I need to do 2.8. I have to type git commit -im and a message. Let's give it a try. Git commit -im including command. Okay, give me a second. Git discovery across, not a Git repository. Oh. Yeah, I know where is my mistake. I have to be inside the Git folder. ls. So I need to say cd a. Now I say ls. So if I go to my folder here, git clones, I have to be inside this folder. So I see these files, I see those files here. Now I can type again git commit -im, and I was saying adding a text line. Okay, now it accepted my comment, why I did that change. The same when we wrote in the Windows tiny window, we wrote what we changed and the reason. This is the option to do it in command line. Now I need to send it to the cloud, because Git, working with Git or sending your data to the cloud requires two steps. This is the first one, telling the reason. Second is sending it up. So what it says my text file? It says git push origin master. That's the command that needs to pass in the terminal. Git push origin master. What's your username for GitHub? Well, the one that you assigned it. Here is where comes the complication, or it's a slight complication. I already solved it for me, but we need an extra step for you. If you put your password, let's say, going to fail. It's not your password what requires as password. So what they is saying, username, password, this says support for password authentication was removing this date, it failed. What is saying? And the good thing is I can do this. I can copy these recommended ways of authentication. I can open a new tab. Okay. There is text about it. Yeah. Cloning with CLI suggestion. Doesn't say much. Okay. Git passwords. Where is Git passwords? Okay. Now this is not it. Let me see. Did I copy the wrong one? Let's start at about. Yes. Okay. How you solve this one is the link. The link looks different on when I use it, but what we need to get is what is called a token. Let me see if I can. Why it doesn't open? Okay. Okay, where is my notes? Where are my notes? Show all notes. Okay. In case, what we need to do to solve that is we need to go to our account here. And we're going to go to settings. Here, we're going to ask for SSH and GPD keys. Was this way? Yeah. And then we're going to generate organization. What's organizations over here? Let me see. Now it has to be this one. Or code security. Give me a second here. No, this is not the one. Developer settings. Developer settings. Yes. Okay. So we go to your icon here. Settings. The last one, developer settings. Okay. Here you want to click on personal access tokens. Tokens classic. Okay. What that is, this is the password that GitHub is asking. It's not your password of the account. When you work in Linux, it's not asking for the password of your account. It's asking for this. So we're going to generate a new token. Generate new token classic for general use. But to say class remote sensing. You can define how long this password is going to last, for a month or for a year, or no expiration. Is you can put, say, 30 days. So here in the select scopes, to avoid issues, you want to select them all. There is not select all. And then you say generate token. Okay, now, and this is the hardest part. This key won't be stored in GitHub. You have to immediately copy it. Open Word or any recording somewhere where you can store it, because it won't show up again. This is the only time you will see it. So GitHub token.
So you can use this token for the next
It-
3 months. what you said.
Yes, so if you say 90 days, it's going to last for that, and then you have to generate the same step again. So Git token is going to put it on my desktop, save. Okay, now I have the token. So now I go back to HydroShare. So my last step is git push origin master. Git push origin master. Username, you know your username. Password. Make sure you don't include the spaces. Copy. Control V. Enter. Done. Remember the phrase that we changed on the last notebook? Okay, did you understand this part? This is the hardest part of synchronizing your repository on HydroShare to GitHub. So this is how these two words have been connected. Okay, very good. So yay, you got your GitHub token. It will last for the period that you say. Let's go now to our repositories. Let's check. It was notebook number 1, right? Okay. I think it was this one, extreme basic. Let's see if our change is at the very bottom. This is an example of using GitHub and HydroShare. That's how you think. Fun? Fun. Okay. Now, okay, how are we on time? We have till 11:30, right? All right, let's take a break. Okay, so what you have done so far is you're working on campus, you didn't bring your laptop, okay? You are here, you brought GitHub, you are in Jupyter, you did this back and forth. But you have another computer at home or somewhere else where you want to work. How do I bring these changes here? I don't need, no, I don't need to download. There are two ways. We need to do it for Windows and for HydroShare. This is the step is missing. Remember, it's always a triangle. You're working on one computer with the cloud, that's good. But then if you have an extra computer, how do I make sure that if I work here, everything gets synchronized? So, because today we added text. This text is here, but it's not here. So I need to bring that text here. How do I do that? That's the, we need to sync it, right? It's like using Box or OneDrive. Box and OneDrive are doing that synchronization for us. In this case, we are the ones who have to do that synchronization. Okay, let's check what we can do. Okay, let's go to the GitHub desktop. GitHub desktop. So what I need to do now, I'm in another computer, or I was working on campus and on my laptop, I need to synchronize what I did on campus to my local computer. So what I need is I need to do fetch. So I need to click here. That first I need to make sure that here I'm in the right repository. I might have 20 repositories here. And I was working on the beginner guide to carry out the stuff. Second, I need to fetch origin. Says okay. You see this icon? It says that something in the cloud has changed. And that was when we did the HydroShare stuff. We put that text line, we send it to the cloud. Now my GitHub window is saying there is one change there. So do I want to bring that updated file to my laptop? I say yes. Now the files on my laptop are the same version as they were in the cloud. Okay, so that's the window. Up to there, the GitHub interaction ends. So now that we know this, so that's the last step for Windows. Fetch the changes that are on the cloud to my local machine. Now let's do it the other way. Let's synchronize, let's update the files in HydroShare. So now I go to this location. I'm on the GitHub repository, the local GitHub repository, and I'm going to say, going to change this term. Observe. Just a minor change. Save. Close. Has detected a change. Column name, change it. Better description. Commit to master. Now I need to push. Okay. Because I'm working on my local computer, but also I'm working on HydroShare, right? So I need to make sure that this minor change that I did also is seen in HydroShare. Okay. Now I need to go to HydroShare. Where is HydroShare? Okay. HydroShare, where is my here? Okay. Let me see. I need to go to HydroShare. Let's close everything. Okay. I need to do my steps. First, where I am, ls. Oh, I'm in the, which folder aligns with that? This one, I'm in the master folder or the root folder. I need to navigate to where? Git, I need to navigate to the Git folder. The Git folder is in Git clones, a beginner guide. I need to navigate here. So I need to put cd git clones / a - tab. Now I'm inside this folder. I can confirm it with ls. I see these names on my text file. All right, nice. Now I'm going to check my text file. How do I pull files from cloud Git repository? I need to pass the command git pull origin master. Git pull origin master. Done. That small change that I just did on that text file now is updated into HydroShare. I completed this synchronization. This is the, so you have learned how to do this, how to move data from two environments, the HydroShare to your Windows to the cloud. You have learned the two ways to do it. Right? Questions here. Remember, you're doing a tutorial, and I know the steps. So, okay. Questions. All right. All right. Last step. We cloned a repository, right? We clone a repository. We didn't create a repository. For the homeworks that you're going to be doing in the class, you have to have your own repository. Your own repository, that means that as you're working in the lab that we're going to be doing, you're going to be thinking, pushing your data to your repository, and I need a screenshot of your GitHub saying, assignment 3 is in GitHub. Okay, so for that, we cannot clone a repository, we have to create a new one. So how do we create repositories? Like, let's say for the statistics class, I want to have a GitHub repository. For my physiology class, I need a repository. For my remote sensing, I need a repository. So you can actually create it for every class. You can have a repository and be doing this synchronization. So your data, your homeworks, your data is always stored on the cloud. You don't have to store it on your computer, or you have a backup on the cloud. So the last step of all these masterclass on GitHub is creating repositories. So we go to GitHub again. How do I create a new repository? Brand new, 0 files. Okay, so I'm going to click on this, click on the cat. Of course, you have to be logging into your account. Click here, new. Okay, so you can call it, for example, CEE free. You can give it any name. You can say soil moisture forecasting. You can call it USU CEE, this class or any other class. This is brand new. Description, assignments, and data from this class in spring 2023. Here is where you choose, you want everybody to see this repository or you want it to be only for yourself. Remember the example about Microsoft building Windows here? They choose the private version. So you can choose private, and because it's your homework and you don't want anybody else to see how many mistakes you make on your homework, okay? So you say private, now this is my data, I don't want anybody to find it. But still, if you're private, GitHub have an option to add a friend. If they have an account, you can say add a friend, you enter their username and they can see that private repository. Okay, so private, you can add a README file, and this is very recommendable. Add a README file. Git ignore, and this is a template like the Git ignore is telling you what files. Let's say you have a folder with text data, image data, AutoCAD data, software like .exe files in that folder. It's a mess, that folder. So you don't want to synchronize certain file types. You can, in the Git ignore, you can choose that. But for now, let's leave it there. Here, choose a license. Choose a license means, do you want people to give you credit for that, for your code or not? Do you want not to include a license? Or the code is free, anybody can use it, I don't care, I was tired, I didn't like this class. Okay, so you can choose any. What's the most recommendable? It depends. Every license has different options. Typically, the GNU general public license is fine if you are doing your data free. And then you say, I'm create repository. There you go. So you have only 2 files. You have no data here. Okay. So you have a README, you have a license. How do I add files here? Add files here. Upload files. Choose your files. Let's upload whatever I have here. Scopus. Okay, I choose 2 files. I say initial files upload for demonstration in class. Commit directly to the main branch only if you're working alone, or if, yeah, this will be by default. If you're working on a team, this might be the better option, but typically you just need to commit to the main branch. Commit changes. You see now the new 2 files there. Okay, now can I bring this new repository to my GitHub in Windows? Let's see, what's called? USUC assignments. I go to GitHub desktop. current repository is another one. We need to say clone repository. What do I call it? CE. This one. I'm okay where it's going to clone it. Okay. It clone it. Now I go to my folders. I was in documents, GitHub. Here is my new repository. Here are my files. And from here, you change those files, synchronize up, you go to HydroShare, synchronize, pull it, and then fetch it, and then pull it. And so you see, it's always a triangle. Okay, so with that, you have all the steps in GitHub to work either in Windows, in a cloud environment, synchronize files, how to get the token on GitHub if you're working HydroShare, because as part of your homeworks, as we enter into programming next class, then you will be building your own repository where you will be uploading your files, your homeworks, and you will show me a screenshot of your GitHub where you uploaded that file. So that's to motivate you to use GitHub either by the terminal, either by Windows. But you will always use GitHub. Okay. And I'll be here to help you with any issues. Okay, questions? Fun? No. I mean, for me, all of this took me half a year to understand all of this. Okay. But you are learning from all that process and thinking and summarizing everything until I found this recipe of commands and options to make it work just nicely, and you saw it today. So again, you are new to GitHub, or you might have never seen these options. Just ask. Also, we have the video today, so you can always go to that and make reference, because you say he explained it somewhere else or at some point. So that's it for today. All right, very good. Well, with this we finish this. Stop sharing, stop recording. Yeah.